Okay, let's start. This is the first slide, which is giving you the list of all the CLOs. And CLO 1.1 is describe fundamental concepts. Where is my pointer? Here is it is. Where is my pointer? Pointer is there or not? So describe fundamental concepts. Just a minute, I have to set my pointer. Visible, visible. I don't know. Okay, CLO 1.1 describe fundamental concepts of algorithms design and analysis. Fundamental concepts of these two things: algorithms design and analysis. And in it we will cover asymptotic notations, complexity measures, and correctness proofs. Okay, and what are the learning objectives of this lecture, which is about CLO 1.1? So in this lecture, we will understand the need of analyzing algorithm. Why we analyze algorithm? This is the question, huh? This is the question, that why we analyze algorithm. So what is the need for it? We will try to understand it first, and then we will learn if we have to analyze, if we have to perform the analysis of algorithm, we can perform the analysis through these by using these asymptotic notations. What are those asymptotic notations? Big O, big omega, and theta. We will understand, and we will understand how to use them for analyzing the algorithms. That is our second objective that we will achieve in this lecture. And then evaluate time and space complexity. Time is one type of complexity, space is another type. There is another one, huh? Uh, but anyhow, in algorithm, we will calculate the time and space complexity of each and every algorithm in our different topics. So how we can evaluate time complexity and how we can evaluate space complexity, we will see them. And then finally, there are different types of time and space complexities. We categorize them into what? Best case, average, and worst case. Best case is, what is best case, what is average case, what is worst case? We will see. Yeah, we will see, and you will understand. This is also an our objective of this lecture, or from this lecture you will understand that what's the difference between these three terms. And finally, how we can prove that this algorithm is correct or not. So prove algorithm correctness. How we can prove? We will see different 2 to 3 different techniques through which we can calculate that the algorithm is correct or not. We will see them. Okay, importance of analysis, because this is our first objectives. This is our first understand the need of analyzing algorithms. So now the slides are starting in that way. Importance of analysis. Why the analysis is important? The first point is scalability with large input sizes. Some algorithms can perform good on small input data. And if you will keep on increasing the size of the data, the performance of the algorithms will be shaken. It can happen. So algorithms, can you change your seat, please? Yeah, I'm asked. I don't know the name. Yeah. Yeah, I want to see you, okay? So come in front of me or here, okay? Or just change your that seat. I want to make my eye contact, okay? When I will have eye contact with you all, then I feel good. And if somebody is hidden from me, then it is, I don't know, different kind of feeling emerge in my personality. Anyhow, so algorithms can behave differently with the small input data and with the large input data or with the medium size of input data. And you have to see that what is the behavior of the algorithm on these different sizes of the data. This is called scalability. This is called scalability. So, and what is the, you have to see that what is the behavior of the algorithm on the input, on the large input of data. On the small, everything will be good, okay? But what will happen with the large input data? That is what you have to judge about that algorithm. That is the topic of scalability. So, an analysis is compulsory. The analysis is needed if you want to test the scalability of the algorithm, which means that algorithm is good for the large size of data or not. Huh? Number two, comparison of multiple programs or multiple algorithms. If you have different solutions for one problem, this is one problem, and if you have different solutions for it, 3 to 4 different solutions, and you want to check that which one is a better solution for this, and then you have to do what? You have to compare these 3 4 different solutions. You have to compare, and only then you can answer that this algorithm is better or not. So it is also important for the comparison. This analysis is what? This analysis is also important for the comparison. Number 3, trade-offs between speed and versus memory. When you will uh, this depends on theoretical analysis or empirical analysis. But speed versus memory, if algorithm is taking very much less time, then at the same time what space this algorithm is taking, huh? I don't know, maybe small, maybe larger, anything. And if the algorithm is taking less memory, then at the same time what space that algorithm is taking, it can be less, it can be large. So you have to study this. You have to study this, and you have to see, is there any trade-offs between them? One thing is large, other is less, other is less, other is large. Huh? You have to study this. And then if you will be expert in analyzing the algorithms, only then your foundation will be ready for the advanced topics of algorithms. So foundation for advanced topics. And what are those topics? Optimization is one topic can algorithm. Amortization is one topic. Another, NP completeness, another. You can understand this one, but there are advanced concepts in these topics again. And if you want to understand them, then this foundation of analysis, that you can do the analysis, that is compulsory. So these 4, and there are many other points you can explain, but I think these 3 4 important points are highlighting the importance of the analysis, that why analysis is needed. And now, what is algorithm analysis? Um, or I can give another title to this slide, Introduction to Algorithm Analysis, okay? And here on this slide, I am giving you the definition of the algorithm and what is the objective or aim of designing an algorithm and what is analysis. Okay, I'm giving you three definitions. So the definition of the algorithm you already know from your previous courses. And that definition is what? Step by step procedure to solve a problem. If I will give you the problem, you will write a step by step procedure on the paper to solve that problem. That is called algorithm. In any style, either in a, when you say it pseudocode style, it is more close to some programming language. Huh? When I say algorithm, it is more close to mathematics style of writing. Huh? That is the only difference between pseudocode and mathematics normally. So, so you are free in algorithms. You are free actually. You can write by using any style, either some programming language syntax or some mathematical syntax or some other whatever you want. But you have to give steps, logical steps in a sequence. So step by step procedure to solve some problem is called algorithm. And then aim of design. What is the aim, objective of designing some algorithm? We design algorithm because we want to get optimal solution from it for our given problem. Huh? So that is the aim of designing an algorithm is what? To provide an optimal solution for a problem. So easy. Huh? And then analysis. What is analysis? Evaluating efficiency and correctness. What is analysis? Okay. Analysis not only time and space evaluation of time and space complexity is analysis. No, that is the third one. Proving correctness of the algorithm. Huh? Evaluating efficiency and correctness. Efficiency, okay, here you can take it as time complexity and space complexity. You can take this efficiency as time complexity and space complexity. And this is the third thing, correctness. And these three things concludes the definition of the analysis. So, okay, now key question. How fast? How fast is this algorithm? It means I'm asking about time complexity. How much this algorithm is taking memory? It means I'm asking about space complexity. Is this algorithm correct? It means I'm asking that about correctness proofs of that algorithm. So it is always first step that you design the algorithm and then you will analyze the algorithm. And when I say analyze, you are analyzing these three things. And then we will implement into some programming language. And then we do the experimentation of that program with the data, input data, and you are getting output. This is the process, huh? Designs, there are different design strategies and algorithms. Some are called searching strategies, linear search, binary search, huh? Sorting strategies, merge sort, quick sort, many you will see. Greedy approach. There are different algorithms related to this greedy approach. Greedy algorithm is one. You will study in AI, inshallah. Divide and conquer is one approach. Decrease and conquer is another approach. There is only minor difference. Otherwise, it is one category. Divide and conquer. This is what divide and conquer. Dynamic programming. Okay, you will see what it is. There are further two subcategories in it. You will see this is also another strategy. Graph algorithms, how you can handle graphs. There are different algorithms. And similarly, randomization, approximation, recursive, branch and bound. There are different, but it doesn't mean that you will study all. No, you will study some of it. Applications of design and analysis of algorithms, where you can apply this design and analysis of algorithms. You are applying it in computer programming. in programming. Programmings are the next part of your previous algorithms. Huh? You are applying it in big data, pre-processing, networking, artificial intelligence, everywhere. In computer science, you have algorithms everywhere, huh? Because it is the first step to solve a problem. You are not always going directly to write a program on computer until you have a small problem, huh? If you have a small problem, then you are going directly on a computer to write the program directly. But if it is a big project, how you can go writing program for that project on a computer directly? No, you cannot. You have to build, you have to make plan on the paper. That plan that you will make, it's algorithm. Hmm? And some are managerial stuff, but some is the stuff which is directly the solution of your product. How you will build that. So these are the different. Write any name here, and then algorithm will be what? Application. Write any name here. Now, algorithm analysis. Definition of algorithm analysis. Previously, you have seen a flash of definition of analysis here. Huh? Now you are going into detailed definition of algorithm analysis. Why it is needed? Sometime I have a problem and I have one solution for this problem. Then I have created another solution for this problem, another solution for this problem, another solution for this problem. And now if I have 3 to 4 solutions available for this problem, how can I know that which solution is the best one? Only through analysis. Only if I am able to do analysis between all these solutions means these 3 to 4 different algorithms. Algorithms that you have made for this problem or your team has made for your problem, and you are a manager, you want to judge that which one is the best, which one is better, or which one is the best one among these. How you can judge? Only if you know how to do the analysis. So, and for the analysis, you have to do what? We have to calculate efficiency and the correctness. Correctness proofs. So problem can be solved in more than one ways, okay, like this. Then we can analyze the efficiency and correctness of those. So we have to analyze the efficiency, time and space complexity, and correctness, that this algorithm is correct or not. These 3 things, we have to analyze all these 3 things for all of these 4 versions. And after this analysis, we will see that which one is best. And you cannot, every algorithm will give you some big O value, huh? And the proof is correct or not by that proving method. Then you will see that which algorithm has best values. You don't know how to calculate these values? Wait, you will do that. We can analyze the efficiency and correctness of these solutions, and then finally, whatever the solution is giving us the best values of efficiency and correctness, we will select that and we will implement that into some programming language as a program. We will implement them. And that would be our best suitable solution. Huh? This is algorithm analysis. Still, up to this point, the definition is same as you have in the previous slide, but written in sentences. There it is written in short way, efficiency and correctness. And here we have a figure and nothing else. Otherwise, concept is same. Okay, now efficiency of an algorithm. Efficiency of an algorithm. Efficiency normally means time and space, okay? And if you will make it more short or abstract, it always means time complexity, okay? Normally in algorithms, Whenever this word efficiency will come, it will normally means, it always means space and time both. And if you want to make it more short, more abstract, then it always means what? Time. Because space nowadays is not an issue. We have too much memory. Hard disks are available cheaper. This was the issue in old times. So anyhow, so efficiency, we can analyze it in two ways. One is priori analysis, other is posterior analysis. One is priori analysis, other is posterior analysis. Priori analysis, some analysis which you will do before. Before what? Before implementation. Before implementation. Before implementation, before writing program. The analysis, the theoretical evaluation that you will, the analysis or threat, you can do the analysis that you will do before implementation is called a priori analysis. In other words, before implementation, it would not be practical, huh? It would be theoretical. So it would be theoretical evaluation. It would be theoretical analysis before implementation. And in this, we will determine efficiency. And what is efficiency? Time and space. Huh? We will determine efficiency using different mathematical models. And what are those models? Asymptotic notations like big O, big omega, theta. And through this, we will calculate the behavior of the algorithms. What is the best case? What is the average case? What is the worst case? Worst case is always with the maximum number of comparisons. In other words, you can say with the I don't want to say input size here now because for this, but you can say with the large number of that is not okay. With the maximum number of comparisons or operations, not comparisons, operations. Here, scalability means large data. Huh? When you have large data, then number of operations will be large. Okay, that is easy. Huh? But I don't want to say here large input data. Okay, I want to say large number of operations because our focus is there. Large number of operations, large time. And whatever the variables you are using, large number of operations, memory will be used accordingly. So, what is priori analysis? This is theoretical analysis that we normally do before implementation. This is easy, huh? Definition easy. And in this theoretical analysis, we will use big O, big omega, or theta asymptotic notation, which are called asymptotic notation. You can also call them mathematical models. We will, in this analysis, we will calculate time and space complexity by using mathematical models like big O, omega, theta for the worst case. The other case is best, average, doesn't matter. Worst case always matter. That is the maximum number of operations needed by by that algorithm. When it is worst case, it is the highest value of the scalability, yeah, with the large input size or whatever you can say. I don't want to say it because it is not correct. If I say large input size data, not correct. Array can be, for example, I can give an algorithm, I can give an array of 10 elements to some algorithm and I can calculate worst case for that, for 10 elements. I can also give an array of 50 elements to that algorithm and I can calculate the worst case for that. And the worst case for the 10 elements and the 50 elements would be the same. Okay. Whatever the, for example, if I say order of n is the worst case of this algorithm, now either you will give 50 elements in the array or 10. It is order of n because it is representing something generally. You will understand. If I will go into detail now, then I will confuse you. Okay. So the simple thing, what is priori analysis? This is a theoretical analysis that you will do before the implementation. And in this analysis, you will calculate or you will evaluate time and space complexity. Okay, khalas, you don't have to say anything else. Posterior analysis, post, after, huh? After implementation. So empirical analysis. Now here we are using, this is theoretical analysis. You have to do it manually. But here empirical analysis, observation, whenever the word empirical is there, it means you have to do that analysis by observation. You don't have to do it manually. You have to do it observation. Something else is going on there. Empirical analysis of an algorithm after implementation. You have implemented your algorithm into the form of a program, and now your program is running on a machine. Running on a machine. And that program, how much time that program is taking, that is time complexity. How much space that program is taking on the machine, because you know the int variable is taking 4 byte, float is taking 8 byte or whatever, you know that in programming languages. So you can just write a statement in your program and it will give you what is the space and what is the time this algorithm is taking. And you are observing on machine. That algorithm is that program is running on the machine. But it is, so then that analysis which you are observing on the machine about that algorithm, that analysis is called empirical analysis or posterior analysis. Understood? And in our course, we are not interested in this posterior analysis. We are interested in what? Prior algorithm analysis. You will do this not by machine, because hardware can be different. And then you will have different space and different readings. But this prior algorithm analysis, whatever you will do, it will be same all the at all the points. Asymptotic notations. I will go with this slide and I will stop here. And then into further details, I will go over. Huh? Okay, I'm stopping now. Okay. This is what you want, huh?